Hello. Welcome back to another recording of I'm sure your favorite class, right? Don't answer that. Don't don't answer that. Uh Today we're joined again by Jules. Usually he's over in this window over here, but he's over in this window today. Well, there isn't really a space for him to sit, but that never stops a cat, does it? Poke him. There he is. Excellent. All right, so here we go. Let's get into it. Today we're talking about maps. All right. So what is a map? A map is a data structure that associates keys with values, right? And so the way that works is when I put something into a map, I put in a key and a value. So I would say something like the key is a string for Jules and the value is Tuxedo Cat. And then the string is Tybalt and the value is Tabby Cat, right? And so the idea is the job of the map is to associate the keys that I give it with the values that I give it. In order to keep things sorted out and to make sure that there's like I can get back what a value I have associated with the key Jules, keys must be unique in a map, which is and so this is I get this question a lot for binary search trees. What happens if there's a duplicate value? Well, most of the time you're using binary search trees to implement this map abstract data type. And so because the binary search tree is your data structure for this data type, you don't actually want duplicates, so that problem doesn't come up most of the time. Or really ever if you're doing a map, right? Maps are frequently templated, and if you use the map from the STL, you'll have to give it two types, not just one, right? Because usually it's vector of integers or vector of strings or something like that. Here, you're giving it the type of key that you're going to be using and the type of value that you're going to be using. And so that means that when you put something in, you're going to be giving a key of that type string and a value of that type student. So for instance, with this map with string and student, string has to be some unique student identifier, right? So let's pick email address, right? So everybody has a unique email address, hopefully. And so we have that email address and we associate it with a student object, like a student type of a student classed object. And so that student class object might have more information in it, like full legal name, campus ID, pronouns, et cetera, right? So then whenever you want to retrieve a student, the idea is with a map, you can do it efficiently by putting in the email address and then get out the full student object. So the point of a map is to give you these keys, like actual, do I have a key on my desk? No, I don't. Give you keys that allow you to retrieve values back efficiently. There are two types of maps. Ordered maps and unordered maps. Ordered maps efficiently will give you back all of the values, which in our example before would be all of the students, in key order, meaning if we're using an ordered map for our email to student map, then we can get back all of the student objects in sorted order of their email address very efficiently. Linear time. That we can do it in linear time, which is fast. That's faster than a sort. The fastest comparison sort is n log n, which you'll see proven to you in algorithms, and then you'll have to prove it yourself. Yay! Unordered maps are maps where you have no guarantee, like you can't efficiently get the values back in sorted order. Why would you ever use an unordered map? They're way faster for doing every other operation. So we'll talk about, so ordered maps in this class, we're going to be implementing with balanced binary search trees. Unordered maps, we're going to get to later. It's like a few topics away. We spend a lot of time on balanced binary search trees. but we're going to be using hash tables for them. And hash tables are a mega useful data structure, and the no-brainer. They're basically designed to be the implementation for this unordered map abstract data type. And remember, this is an abstract data type. There's a lot of different ways you can implement maps. We're going to be talking about efficient ways to implement them in this class. So this hat check metaphor is, I don't think I came up with it. I don't even remember where I found it. Maybe I did come up with it. Who knows? But the idea is, back in the old, I would have said coat check, so this can't be mine. Back in the olden days, everyone wore hats, or most men and a lot of women wore hats, right? And it was considered rude to have your hat on indoors. So at fancy places, you would go up to the hat check person, you'd give them your hat, and then they'd give you back a little like slip with a number on it, right? So then, if you think about it, that's like a human implemented map, because you have a slip of paper, which is the key that you get your hat back with, and then the value is your hat. And so, suppose you got to pick the number, or you wrote like your name on a slip of paper, or you pull one of those numbers, right? You'd give the number and the hat to the person, and then later you could give them, and they would go store that. And then later you give them the number and they'd give you the hat back, right? So there's two operations here. Let me actually put this slide in there. Two main operations are put key value, store the value in the map, retrievable by its key. And then get, you just give it the key and it returns the value. Retrieve the value with key, with supplied key. Okay, and so those are the two main operations. You can also do like an update and things like that, but this is the idea, is that you put something in with a key and a value, and then you can go back later with the key and get the value back out from it. So you've probably run into maps before. If you took 201 here at UMBC, you probably learned about dictionaries. Dictionaries are unordered maps in Python. They're implemented with hash tables, not with balanced binary search trees, but hey. Or you possibly encountered, if you've used JavaScript, associative arrays are implemented. They're maps, basically. They're also a common data storage format. If you've heard of JSON files or YAML files, or to some extent XML files, those are all maps. They're organized as maps. Even HTML is kind of a map in a way. It's more of directly a tree. But let's go look at PokeAPI.co as a fun example. Actually, I already have it open over here. So let's put in a Pokemon. I'll take suggestions, Jules. Jules, what Pokemon? Jules! He hears me. Julesy, what Pokemon? Meowth? I think Meowth is one, right? Alright, so here's Meowth. Look at all this stuff we get back. But if we go down here, we can see that it's actually like it's a map kind of organization, right? So the key here is abilities, right? So I have this key abilities, and it has with it associated a list, right? So sometimes the question I usually get is, well, what if I want to, if keys are unique, what if I want to associate multiple things with a key? Then the value you give for that key should be a list of things, right? And that's the case here. So Meowth has 3 abilities. And so if we look, here's the 3 abilities, right? And so they're each in here as other maps. So this is a map where there's the key abilities that has associated with it a list, and that list has 3 more maps in it, and each map has the key ability with then the key name, pickup, and URL, so you could go find out more about this ability. Then the key is hidden, which is false, and then the key slow, which its value is 1. So we have map a map of strings to lists of maps of strings to other maps of strings to strings, right? So it's that you kind of keep embedding these things inside of each other over and over again to represent a fairly rich data structure here. Look, there's 93 different moves here. There's these different stats for it, and so on and so forth. This is a map. This is a map. This JSON satisfies all the specifications of the map abstract data type. And that's it. That's all I have to say about maps. As we do more work on balanced binary search trees, we'll be seeing how that we implement these map methods efficiently, while also still allowing for all of the values in our binary search tree to be output in sorted order of their key, which is the big feature that differentiates balanced binary search trees from hash tables, is this ability to get things out in order. All right, that's everything. See you later, guys.